audio-wise? Awesome. Okay. Thanks for joining this session. Thanks for your interest. I heard I had some pretty stiff competition actually next door where they walk all through the nice new Helm v3 features in the workshop. But I think I'm gonna have a nifty little trick up my sleeve here for you as well, which is how you can turn your Helm chart into an operator and actually run it like an operator on cluster with, in the ideal case, a single command. So at this point in time, I usually get some confused looks from the audience because not everyone knows what an operator actually is. So I'm going to start with some very basic questions to kind of gauge a little bit the knowledge here. Who knows what a custom resource definition is? CRD. Okay, almost everybody. Awesome. Who has heard and has a good grip on the operator pattern itself? Okay, couple of hands. All right, so that's where we are going to do a quick level set, right? So if a CRD is our way of introducing basically new object types on the cluster, the operator is what makes these useful, right? If you have a CRD defined and you register it on your cluster, which you, by the way, need the cluster admin privileges for, and you create an instance of that new object type, nothing happens, right? Other than a couple of etcd database entries getting created. Nothing really happens on the cluster. So what needs to happen is there's a custom controller in the background who starts reacting on these custom resource definitions popping up, getting modified, or getting deleted. And that's exactly what an operator is technically. It's a custom controller running on the cluster, interacting with the Kube API, and watching its custom resource definitions. That's what it does. And that's the chance to make an operator a really valuable piece of software, because what we see is that operators are the place where you basically codify the knowledge how to run an application. This is the type of knowledge that usually sits in the brains of admins controlling the application outside of the cluster in sort of scripts and complex continuous delivery pipelines that are all outside of the cluster. All that is getting codified in software and runs inside the cluster and makes this available behind a custom resource definition. So it's a native object, right? It's a native Kubernetes API, and you can create it with the regular kube control tooling. And then the operator on your behalf will kind of always look at what is stated in the CRD, in the spec section, and what is actually currently existing on the cluster, and will try to make that match, right? And it does this in a software loop. So basically an operator is a big software loop looking at the CRDs out there and try to make that happen. And usually what it does is it uses the lower level, more basic Kubernetes objects and functionalities to do so, right? So that's kind of what an operator does. It's acting on your behalf and providing you a managed service-like experience. So why would you want to do something like that? Now, stateless applications are very easy to do on Kubernetes, right? Deploying applications is also very easy these days, thanks to Helm on Kubernetes. But looking at the application over its life cycle, you know, it only spends like 10% of its life cycle time in development and then deployment. The rest of the time it actually spends running on the cluster servicing the users, right? And that's where day two operations come in, like common events, like, you know, if it's a database backup, restore, failover, failback, complex reorchestration and reconfiguration that requires sequencing. All these are day two operation management tasks that are a little bit harder to do with the out-of-the-box features of Kubernetes, right? So automating these operations as part of the operator, a piece of software sitting inside the cluster, right next to the application, is really what makes an operator valuable. The other thing for the users is, it feels like a managed service you get from one of those cloud providers, right? So if the cluster admin installed an operator on the cluster that, for instance, gives you a MySQL database, right? A user could come in and create an object called MySQL database cluster and basically ask the operator for a database cluster as specified in the spec section of that object. And the operator will do it for him, right? He doesn't need to know how that actually works and what's the best practice to deploy a MariaDB in production in Kubernetes and what are the best configuration values. That's all inside the operator. What the user sees is a single object that's basically his new user interface of asking the operator to do something, and the operator gives it the service, and it life cycles this instance over time with the additional features. And the cool thing about that is that this happens constantly, right? So as I said, the operator is a software loop, basically, right? So if something is bypassing the operator, like me as the user accidentally deleting that very important config map that had the my.cnf inside, the operator is going to restore that in the next reconciliation loop, right? Which is going to happen in the next couple of seconds. So you have also automatically remediation of any configuration drift, which is ensured by something that runs inside a cluster and not outside, trying to impose itself, right? This makes it very portable and integrates very natively with, you do things on Kube anyway. Now, with that, why would you run your Helm chart as an operator? Well, obviously there's nothing wrong with Helm charts as such, but what you get in addition when you run it as an operator is a very nice user interface, right? You suddenly have a top-level object, a CRD that represents an instance and actually a release of your chart, right, on cluster, which is the go-to point on cluster people can go to reconfigure this, create it or delete it or whatever without any kind of additional tooling, right? Customers that use this love this because it enables GitOps quite easily, right? It's just another Kubernetes object that I need to basically kube control apply -f, right? It's as simple as that. There's no additional tooling required. Also because it's a CRD, it is now subject to the standard kube RBAC features, right? So you can forbid certain users in certain namespaces to create a release of a certain chart, right? If you wanted to do that. Maybe it's a complex or resourceful application, or maybe it is attached to a license, right? You can actually do that with native kube features. It's just another object from this point on. For Helm v2 users, as Helm is approaching GA, you get to basically have your charts run without tiller on the cluster side, and you have the operator have its RBAC tailored to what it actually uses, right? And the SDK, which is a component you can use to create such operators, helps you to do. So instead of like having a component on cluster that needs to have cluster admin privileges, you have a component as in the operator based on your Helm chart on cluster that only has enough privileges to do what it needs to do. And it also can be, again, scoped down very easily to just a particular namespace so that the operator doesn't even react to some of the objects popping up in other namespaces. And finally, the releases are applied constantly, right? So again, there is constant remediation of any configuration drift when you delete an object that was deployed by that chart or is part of a release, right? So the operator will restore that in the next reconciliation loop, which is, on a not too busy cluster effectively immediately. So you get a very nice handling, a very easily approachable way of deploying software or instances of software for users that are not cluster admin. Now, how do you get to this? I'm a product manager at Red Hat. I should have probably introduced myself. My name is Daniel Messer. I'm a PM at Red Hat for something we call the Operator Framework. This is an open source project aimed at Kubernetes, the Kubernetes community, to serve on the one hand those people who want to write operators, as well as those which are operating clusters and want to run operators at scale on a cluster in a very safe fashion. An operator is really like a kernel extension on a modern operating system. You want to have some special handling around that, right? You don't want to just have every user be able to load those and do potentially disruptive stuff on your cluster. Very similar an operator. CRDs are always global, right? Operators are usually very privileged as well. So there's a component called the lifecycle manager, which makes that a little bit easier, and also centrally manages the operator installed on the cluster. Now, the operator SDK is looking at the developers who are experts in how to manage an application. These are usually ISVs or people who wrote the application, and gives them several options to actually create an operator. Most of the operators today are written in Go, which is basically straightforward because Kubernetes is written in Go, and there are very mature libraries like controller runtime that allow you to connect to the Kubernetes API. What the operator SDK does here is scaffolding a lot of the boilerplate code that you would always need to write if you want to write an operator interacting with the Kubernetes API. For those who are not too savvy in Go, there's also the option to create operators based on Ansible playbooks. So Ansible has very nice modules for interacting with Kubernetes, and you can basically write playbooks that then run as part of the operator, reconciling your custom resource definitions. And then there's the interesting stuff for you, which is the Helm-based operator, which is also part of the SDK. That's basically an approach to write an operator without writing a single line of code at all. What you do is basically you convert the chart to an operator which runs on cluster. And with the framework, you also get some additional testing and verification tooling to make sure your packaging is correct, the operator behaves after best practices. And then you can basically also publish and share that with the community on something we call the Operator Hub, which Diane is going to talk about in the end a little bit. Now, how do you actually create an operator from a Helm chart? It's fairly easy. This is the single command that makes that happen. What you essentially do here is you create a project from the Operator SDK perspective, which is just a directory with a specific layout. And what happens here is that your Helm chart will be tied to a custom resource definition. That's at the very basic level what a Helm-based operator does. It executes a Helm chart up on the presence or modification of a custom resource definition. And this command scaffolds this custom resource definition for you. And it also takes your existing Helm chart, in this case from the official chart repo, as an input. So what it does is basically creating a folder layout that looks like this. And for those of you doing Helm charts regularly, you'll see that Helm charts directory there looks very familiar. That's the chart itself, right? That's the unmodified version of the chart that has just been copied basically into the subdirectory. And then there are a couple of additional things here. There's a build directory which contains the Docker file. This is how you build the operator. The operator on the cluster is a pod running with privileges to connect to the Kubernetes API as part of a normal deployment. That's really what it comes down to on the cluster. It's really as simple as that. To deploy this pod, we give you all the necessary basic Kubernetes manifests here. There's a deployment, a role binding, and a service account, which has the necessary RBAC for the operator to be allowed to create stuff on cluster. This is where it's usually sometimes a little bit trickier than just the single command that I've shown you on the previous slide, because we kind of need to be very specific in Kube about the stuff we want people or service accounts in this case give access to, right? So we need to be listing on a per API level, on a per verb level, the rules that we want this operator to be able to do. And the SDK helps you with scaffolding that to like an 80% solution by looking at your chart, right? So it will look at the objects that are part of your chart and create the required RBAC for that. It will also automatically require or create the required RBAC to watch and create CRDs, or just watch CRDs, not create CRDs. And that is usually fine for 90% of the charts, right? Sometimes there is an additional thing missing because some stuff is wrapped in templates in Helm, and we cannot just guess when that will materialize on clusters. So usually things that are missing are like pod disruption budgets or finalizers or stuff like that. But it's very easy to add in this existing role binding. And that's basically what makes up an operator, right? It's the chart. It's the base image that connects your chart to a custom resource definition. The custom resource definition is also already scaffolded and named after the chart for you. So there is essentially not a lot that you need to modify. There's one additional special thing, which is called the watches.yaml. This is making the actual connection between your Helm chart and the custom resource definition, the object your operator introduces. Don't be confused by the location of that chart. This is the location that the chart will end up inside the image of the operator, right? But that's basically it. You create a custom resource definition, the Helm operator makes the connection to your chart, packages this up for you in an image, and you run it on cluster. That's all that happens, right? You take the chart, create the operator image from it, you deploy that on cluster, you deploy that with the CRD, and that makes your chart available as a service to the user. And then you can create native Kube objects that suddenly look like databases, application servers, message queues, and the operator will deploy those for them based on the chart. So far, everyone with me? All right, then let's do what every good demonstration at a conference does, go down in flames. I have an example operator here. It's not Tomcat, it's CockroachDB. I'm a big fan of that database, by the way. And I have created a Helm operator from that. What I did is basically run that operator SDK new command, -- type Helm, and then -- chart equals stable CockroachDB, and it basically created this directory layout here for me. So like I showed on the slide before, you have the chart itself, unmodified, completely the same. You have the Docker file that builds the operator, you have the deployment manifest to deploy that as a pod on Kubernetes, and you have the watches.yaml. So that's all there is, and the only thing I had to do here is basically in the deployment, which is here in this folder, change or like give the actual location of the image that I created and pushed to a registry, in this case Quay.io. By the way, is this sort of readable for you in the background? Okay, awesome. So that's it, right? An operator is a normal Kubernetes application. So in order to deploy this, what I'm going to be doing here is I'm going to first create the CRD. That's a special thing about operators. The CRDs need to be there first, and then the operator can start, because if there's nothing to register against, it will throw an error. So I do basically kubectl apply -f in this CRD. That's that. And then I deploy the rest of this whole shebang, just like that. And I'm watching my default namespace here, which I happen to be in. And what you'll see in a second is that the operator will come up as a regular pod, right? That's really what it is. And it has the right permissions based on what the SDK scaffolded out. And it will now be able to deploy my chart. So my chart is now a custom resource definition. And the very cool thing about this is that what the SDK basically does, it takes the values.yaml from the chart and makes it available as the spec section of that object. So how does this look like? As every good TV cook, I prepared a manifest here. I want to create a CockroachDB, right? So this is what I do. I create a CockroachDB object, like I create deployments, pods, PVCs, config maps on Kubernetes, give it a name, and then in the spec section, should look very familiar, even says so here, I have all the contents of the values.yaml inside. So nothing changes from the user perspective. He gets all the same values, he gets the same UX, right? It looks like a Helm install, but only it is a native kube object. So I can basically apply that as well, and then magically in the background, the chart starts to deploy, right? I get a release, and there are a couple of more things happening here based on the Helm operator. The object that is now there, I can now basically say, give me all CockroachDB instances, kubectl get CockroachDB, and I have one instance here. And if I look at that, it's a regular Kubernetes object, right? Has an API version, has a name, and here's the spec, right? In the status of this object, I also see what the operator did. So you can basically scroll through the status conditions here. This is basically when it's completely deployed, the output of the chart itself. So it also tells me how to connect to this database. And scrolling to the very bottom, it will basically in a moment say that this release has been reconciled and the database is ready to use. So let's see if I can connect to this thing. I'm gonna run this command here, which will basically launch a CockroachDB SQL client in a container. And that should basically give me, in a second, depending on the Wi-Fi, a SQL command prompt, which means I'm ready to use the database. And there we go. It's live, it's running, and I can start running the application. All right. Now, since this is an operator, right, and there's an object that the operator watches over, which is basically my release, I can also edit that, like I would edit any other Kubernetes object with kubectl edit. So let's say I wanted to decrease the cache size a little bit here. That's maybe a little bit too much for a database. You may want to tone it down to like 35% of the available memory. I edit that, and then the operator sees that I basically modified this and does a Helm upgrade, right? That's what's happening here. And as such, you can see the primary user interface for the user consuming this is now one object that represents the entire application stack. He doesn't need to know anything about what's happening in the background, like that there's a stateful set and a couple of secrets and config maps. It just behaves like a regular Kubernetes application, makes it extremely easy to use in GitOps environments, in CI pipelines, and just feels very native to Kubernetes itself, right? There's no additional tooling. For the developer on the other side, for the people writing the chart, nothing changes either, right? The way we basically bring this to life is we use the Tiller rendering templating engine inside the operator and do basically what would happen in a normal Helm setup, right? So we also support things like the lifecycle hoops or composite charts, right? So there is really no change in the way you write or orchestrate your chart. And we are actually working closely with the Helm maintainers here to enable Helm v3 in this as well. But from the maintainer perspective, nothing changes. It's just a different way of getting it onto the cluster in a way that feels a little bit more at home for people that just know Kubernetes, right, and just want to see Kubernetes things. So I edited my CockroachDB instance, and it reconciled it. It went through all the instances and restarted them one by another. We could do other fancy things here, like, you know, bump up the replica count, and it would do that as well, and spawn new instances. Feels very much at home for anyone who used Helm, both on the developer and the user side, but you have a kube native interface to that. So much for the demo. Actually worked without any problems, I'm surprised. Couple of additional notes. So since this is now an operator and since you actually extended the Kubernetes API, there are a couple of additional best practices we tend to give people who start on this endeavor. So when a chart is updated, right, you basically just copy that into that chart directory and create a new image. You use semantic versioning, ideally, to denote there's a new version of the operator, and you make that available to people. Easy as that. When the chart introduces new values, right, and it's significant enough so that you cannot omit that value, the best practice here is also to bump the CRD version, right, because it's an API, and there are kube conventions about those APIs and their versioning. So when you add new fields that are not optional, you can just bump the CRD version, and that will basically tell users, oh, something changed. I cannot regard this as compatible to the older version of that API. And also your operator will basically, your new operator will only watch that new API by default. So new values should then also yield a new custom resource definition. There's not anything you need to do here explicitly. All the values are supported out of the box, but it's probably a good example to update your example custom resource that you ship with the operator. The small caveat with doing things like this in an operator is managing the RBAC a little bit, because obviously Helm, the operator SDK tries to guess as much as possible from your chart which objects you need to have access to, but you know, there's a limit to that. So here and there you might need to add a little bit of additional permissions because we cannot predict that you would use that. But that's usually just in the very beginning when you start doing this for the first time, and then subsequent things don't change that much that you need new permissions. And if so, you find out pretty soon when you just, you know, do this in an environment. So as a developer of a Helm-based operator, the recommendation is obviously to have a CI pipeline that has a simple, or a CD pipeline that has actually a smoke test inside, which would, you know, install your operator and quickly run it against the sample CR. And that would yield problems right away. And it's very easy to see in the log from the operator itself what's the problem. Chart features, we support everything that, you know, Helm v2 supports. There's no change for the maintainer of the chart. And there are some good practices around updating operators, which we can probably talk about after the session and the coffee break. We have an entire component called the Operator Lifecycle Manager on cluster that deals with that and makes sure that operators are updated, if you want, even over the air, in air quotes, in the background. And you also get a very predictable update path, right? Operators are long-running workloads on a cluster, very privileged. So you're not just going to rip and replace those in production. They need to be updated in a very predictable way, and the OLM allows you to do that. That's it from my side. I think I'm almost out of time. Diane, do you quickly want to give people a hint? Yeah, how they can continue from here.
So I don't know how many of you are aware of operatorhub.io. So the other thing that we've done in addition to this is create operatorhub.io. And what I'm encouraging people to do is take a look there. It basically takes your Helm chart, you run it through the SDK. We have a community repository, and you can make a pull request and add it in, and it's got 72, maybe 75, depending
74
on 74 that are in, and these run on any Kubernetes anywhere. So it's a very generic, it's a very open, public place for people to have access to operators that you build based on your Helm charts, or whether you're doing them with Go or all kinds of different things that people are doing. So it's very open and very public community space for sharing operators. So if you've gone through all the trouble of creating Helm charts for your applications, I'd highly encourage you to try out the Operator SDK and then take a wander over to, if I hit contribute, am I gonna? No, I'm not gonna go, yes. If you go to operatorhub.io, everything you need to know about creating a pull request and getting it added in is all hosted there. And any feedback you have, please just reach out to me on the coffee break. We'd love to see more of your Helm charts up here, and making it easier for people to use your applications. And so maybe we have a little time for Q&A.
Yes, we also have a couple of follow-up links for you. So operatorhub.io, Dan just showed. There's a YouTube video on Helm charts and operators that you can watch, which goes in a little bit more detail on how this interacts with each other. We have OpenShift Commons SIG, which is like a community around the OpenShift project, which deals with operators day in and day out. And there's also the GitHub link to the operator framework, which is the independent open source project that is kind of the umbrella for the operator tooling there. I didn't actually intend to, but I may just give one or two roadmap items that, since I'm the PM, I should probably know this.
Definitely.
On the SDK side, so one thing we are going to do for operators is increase a little bit on the UX side. So you have seen, like, when you get an instance of your Helm-based operator, there's not a lot of information there in the non-YAML output, so we are going to scaffold automatically some additional printer columns on the CRD to make that a little bit easier. We're working with the Helm maintainers to get v3 support as soon as it's there, and it's GA as well. And also continue to invest in this RBAC management system. And one thing that I'd like to highlight as well is we have, as part of the way we handle operators with the lifecycle manager on cluster, a notion of dependency management, right? So we also allow an operator to depend on another operator. So you can actually, like Lego bricks, pull together larger application stacks that are managed by individual Helm charts, or there's a Go operator here and an Ansible operator over there. So you can easily stitch those together in an operator of operators, based on some of the dependency management features that we have. So yeah, that's kind of a quick unofficial outlook for the Helm side of things. Do we have time for questions, or I think we are out almost?
We're officially on coffee break.
Awesome.
We're officially in coffee.
Then it's questions over coffee, I guess.
All right. Thank you guys for your time. Coffee is a wonderful